would have some presentation from the commercial side and also some presentation from the African authorities. So we will start with the commercial side, and I would like to welcome Francis Carruthers, Founder and Executive Director, Strategic Business Development from Lesedi Nuclear Services from South Africa. Please join me. Thanks, Francis.
Thanks. Good morning, ladies and gentlemen, friends, business people, hopefully. I'm talking about small modular reactors, and as you've probably known over the last 2 days, there's been very good presentations made by the Koreans, the Chinese, and the Russians with respect to their technology. And they've probably taken everything I was going to say away from but I will address it and go through it very quickly, my presentation. But first of all, a small commercial break, because I want to tell you a little bit about Lesedi. So we've been around for about 40 years. I've been the founder. So as you can probably see, I look about the age of when I started this business. And Lesedi is really technology agnostic, and our business is really forming strategic relationships in order to provide the best technical solutions for our clients. And it's quite important that people understand that we are here to help and advise, not to tell people what to do. This increases the reach into foreign entities and reduces participation for international OEMs, and understand the local market landscape, and we have an in-depth technical understanding of the systems. We're a multidisciplinary engineering company. We've completed more than about 200 modifications at Kuba Nuclear Power Station in South Africa. We've done more than 90 interventions on 30 nuclear plants globally, and we have about a $200 million revenue, employing about 600 people. Obviously, the climate in South Africa is that we've got two units, 1,000 megawatt units, and we've obviously had to diversify quite to retain our nuclear capability. We've had to diversify our revenue to ensure and to maintain and retain our nuclear expertise. There you can see where we've been working in the world, especially on operating and maintenance. We're in power generation, mining, oil and gas. We've got a complete suite of engineering capability, project management, contract management, operation and maintenance. And this is the agenda for my discussion today. So, just overview. I mean, everybody knows, I hope, teaching or preaching to the converted, that nuclear is zero carbon. And it's very important, I think, for the future of nuclear in Africa that we get that message across loud and clear. Also, nuclear generates very, very minimal waste. It's about 1 million times denser than other traditional forms of mining waste. Of waste from power generation. Yeah, so small modular reactors have been classified as less than 300 megawatts electrical. Micro modular reactors, less than 10 megawatts. I think SMRs are not competing with big build, they're complementing them. So this isn't the competition between SMRs and big build. It's there's a place for both those sizes of reactors. Obviously, from a cost point of view and quality point of view, manufacturing in a factory or in a shipyard or any place, to be able to manufacture it in a modular manner is going to reduce your costs and increase your quality. These things are going to be for large grid, small grid, off-grid, so you can apply them anywhere you like. Passive and inherently safe, reduced operating and maintenance costs, carbon-free base load, and it can be, you can, if you've got several of these reactors, you can actually have a centralized remote operation of them. So I'm just going to get my notes sorted out here. So, as you all know, nuclear power has been declared green form of energy by the EU. And as everybody probably appreciates, renewables has been pushed very, very hard everywhere. And small modular reactors can actually add a lot of value from the point of view of as a base load source and complement renewable installations. Okay. There's approximately 70 SMRs under development in the world. I think there's probably a huge number more than that. I heard numbers of 90 to maybe 100. So there's different types, different technologies being applied, and I suppose in a way there's a bit of a sort of race to be first to be deployed. The Chinese have built a high temperature gas reactor, 200 megawatts, and the Russian Rosatom have a barge. But small modular reactors have been deployed in navies around the world, Rolls-Royce, for example, the French Navy, submarines. So the technology is there, it's just implementing it and modularizing it to be able to get it deployed for land use. So we have water-cooled small reactors, land-based, we have marine-based, which has been discussed, high-temperature gas-cooled small reactors, fast neutron spectron small modular reactors, molten salt reactors, and micro modular reactors. A lot of different technologies, and it's good that we've got the difference of different technologies because there's different applications for each one of those technologies. Economic objectives. We have to, in the sense of the off-grid, you must compete with a total cost of diesel generation. And as you know, Africa's probably economy runs on diesel in by far. I think we've got to create a difference and start thinking about SMRs for the replacement of those diesels. Then we've got on-grid zero carbon, must compete with a baseload storage technology such as the closed-cycle gas turbines, and with carbon tax or carbon capture and storage. That's in the region of 20 to 300 megawatts. And then on-grid low carbon must compete with natural gas, 50 to 300 megawatts. The levelized cost. The information here is probably a little bit outdated now, but it definitely shows you that small modular reactors are price competitive with a number of different competitors, especially around storage. Sorry, I can't read everything from the side here. From the point of view of the gas turbines and with hydro, wind, etc. So you see that from that graph, that definitely is an opportunity to persist with the construction and development and manufacturing of small modular reactors. I think Rosatom discussed the barge concept. I think there's about 6 under development at the moment, manufacturing barges. And there's a huge advantage of that for this type of technology, in the sense that obviously for landlocked countries it's not going to work. And anywhere where you could moor this plant, you can don't have to worry about the waste. It's a less cost to get it to be connected to the grid. And when you want to refuel it, which it could be in 6 years' time, you would just change one barge for another. So there's a real benefit for this type of technology to be deployed. China's high-temperature gas reactor, very similar to the pebble bed reactor that South Africa was developing. And they have already been in operation, I think it says 2021 down there. I think it's been in full commercial operation since 2023. It's 200 megawatts, 2 reactors, 100 megawatt reactors, and one 200 megawatt. So that's already operating. The China ACP 100 under construction, and the interesting thing about this is that I think the current status is that they're thinking that they can build this units in the future in approximately 40 months. That's 3.5 years. Canada, as everybody probably knows as well, they're not represented here during this conference or business meeting, but they've been working very hard with their BWR 300 megawatt, and I think they're ready to start construction very soon, as I understand. The Argentinians, Karim, they've been at it for quite a long time. It's a 25 megawatt, but just showing you that throughout the world, people are starting to build SMRs. New scale. I'm sure the gentleman over there will probably tell you a lot more about where they are exactly today, but Uniscale and X-Energy are really working very hard marketing their technology and finding ways of working with industrial organizations to roll out their SMRs. As you know, SMRs are scalable. It's reduced initial capital costs. Construction time, as I was saying, the Chinese one I went to visit, they're talking about being able to build these things in about 40 months. Footprints for SMRs are very, very small, and you can build them now much closer to industrial and residential areas. Right. So all these different technologies, SMR technologies, have different opportunities to go to the market. And I think it's interesting that some of them don't require any cooling water. So you can put them in places where you don't have large amounts of, whereas large units would require a certain amount of cooling. And I'm just trying to see that. Okay. It's been well talked about inherent passive safety. As you know, some smaller units don't need any cooling to shut down decay heat removed by natural means. No safety systems required. Larger units rely on passive safety systems to remove decay heat. No electricity required to drive safety equipment. No large exclusive evacuation zones required. For example, X-Energy, I think their requirement is, well, they have been licensed probably for about 400 meters, as opposed to 16 kilometers for most large conventional reactors. And hopefully there'll be a streamlining of licensing requirements. And I did see here at the Business Forum, Copenhagen Atomics, they are able to put a 100 megawatt molten salt reactor system in a 40-foot container. Operational life, as you know, most of the reactors that have been built to date are designed for 40 years. And a lot of them now that are coming up, like Coburg Nuclear Power Station, where we've been working, as the extension is now being granted and licensed to be able to run for 60 years. SMRs are designed for 60 years. I think this is quite an interesting slide, because I think it really contextualizes, if I could just find my notes, okay. So we've got a sort of technology pushing and market pulling for small modular reactors. So huge, as you saw, 70 SMRs under construction or under development, and all sorts of different types. The enabling conditions, things like framework policy, regulatory, legal, security, fuel cycle, front end and back end, supply chain infrastructure, talent pipeline, public engagement, economic competitiveness. And of course, maybe you can add in that carbon tax. But the pull is definitely from things like data centers. And I think that the growth in data centers represents a huge opportunity for small modular reactors, offering a transformative new approach that plan data center construction and growth together with emerging nuclear technology. Powering data centers with advanced nuclear technologies notes that data usage and processing are poised to undergo a radical expansion associated with growing need for digital connectivity and emerging functions such as artificial intelligence. So combining a small modular reactor with a data center is really something that can be commercially deployed and easy to justify. Also, as I've discussed previously, it complements renewables. So when renewables, obviously wind and solar, is intermittent, and you need to have a base load to support it. And obviously if you've got, we've gone going through conditions of global warming, weather transitions are making it sometimes less reliable from the point of view of solar and wind. And I saw a tornado rip through America the other day and took out a whole lot of wind turbines. So what are you going to do? You're relying on that power to supply you, and if you haven't got a backup to integrate into the system, you're going to be in trouble. Agriculture. Africa's got a huge potential for exporting their agricultural products. You need often cold rooms. Why not combine a cold room with a small modular reactor? And I think there's going to be a demand from the world for produce that's produced that doesn't have any CO2 effect. So if you're growing something and you're storing it, and you're storing it in a way that's been powered by nuclear, I think you could give yourself a competitive advantage. Also process heat, pharmaceutical, manufacturing, and another interesting, but maybe not so much for Africa, I mean for the whole of Africa, but certainly for South Africa, is that we're going to be decommissioning a large number of coal-fired power stations. And those power stations have already got cooling facilities, they've got connection to the grid, so it'll be a very easy way of establishing those power stations, where they've also got communities associated with them to recommission it with a small modular reactor. So in conclusion, small modular reactors and renewable forms of energy are complementary. Small modules can compete with gas power, with carbon capture. Scalability, reduced initial capital cost, reduced construction times, simplified maintenance, small footprint, inherent safety, no emergency, evacuation zones required, process heat for desalination, hydrogen production, and also geographic flexibility. And that geographic flexibility is certainly a key in Africa due to grid constraints throughout Africa. So you can position these very much where you actually need the power. Thanks very much.
Thank you very much, Francis. We have time for one question for Francis.
I think I've got 10 minutes.
Yeah, thank you, Francis, for this presentation. Very comprehensive, very insightful. I have one question for you about the addressable market, but more important, actually, the economic viability of SMR, because you mentioned the target being the price parity with diesel generation. So do you think that, the target we should seek as a developer of SMR should be like this level of price?
Sorry, Laura, my hearing at my age is going a little bit. I didn't quite catch everything you said. Could you just repeat it, please? Yeah,
my question was about the economic viability, and where do you see the target in terms of LCOE? Because I think in the presentation you mentioned cost parity or price parity with diesel generation.
Yeah, for example, the barges that Rosatom are going to build, for example, are going to have to compete with the current in-country price per kilowatt. It's been delivered by other forms. So if it doesn't, there's no market for it. So you have to make it work one way or another. And when we're talking about data centers, the investment in a data center, as you know, is absolutely massive. And they need regular, consistent, reliable power. And for Africa, especially, I think, Laurent, these data centers need to be geographically placed next to large, communities, and maybe with grid constraints, with transmission and stuff, it's not going to work. I'm not sure I've answered your question precisely, but it's...
I can only emphasize this. I'm a friend, so a competitor, but we are still all in a game that is very nascent. So we are not fiendly. So I can only stress this. This cost position is so essential because if we adhere to the strictest principles of design to cost, so similar parts, easy, simple technology, easy operations that comes with it, inherent safety, this opens up dramatic sizes of markets. And that is something I find underappreciated. So if you ask McKinsey or the IEA, how big is the market for electricity that is going to develop, they say, okay, it doubles from today, it's about 20,000 terawatt hours plus minus nowadays, the global energy power consumption. But if we find sources that bring down costs to the level of coal and below, so 3 cents per kilowatt hour, US cents, this would open up enormous sizes of markets and would allow all this creation of wealth in all the countries, and that's something I find that's our responsibility as an industry to really solve this and slash down costs dramatically. So by a factor 2 and 3, and this is feasible. I mean, in all other industries, this has been done, but it has to be a design feature. So it has to be built in right from the beginning into a nuclear design, that it is simple, same parts, easy to operate in all of this, and scalable in all of this. So I can only emphasize this, and so thank you for a great speech.
So, I mean, obviously, the bigger the power plant, the bigger the unit you build, the more cost-effective you should become. But it takes longer to build it, and that incurs further costs. So if you have something that you can build in a very relatively short period of time, in a very good environment, quality and things, these costs will start coming down when you start getting traction of multiple units, hopefully. Yeah.
I see a lot of questions, but we are time restrained, so one last question.
One thing I think that's been overlooked is the possibility of asset finance for small modular reactors if they're fungible. Like if you could, and this especially in the case of the Russian barge design, project finance has been the holy grail so far for nuclear, but there is a potential to go to asset finance if you could go in and repossess that module or that asset. I'm assuming that most of the cost projections are based on a project finance model, but if you go to an asset finance model, I think the costs would come down. Have you guys looked at that at all, or is it?
To be honest with you, I think the SMR technology providers are struggling at the moment to try and get those costs to a level where they can be. But, a lot of the research and development costs have been pumped into the initial costing. And I think once you get some traction and producing multiple units, then the costs will definitely come down and they'll see it. I mean, building things in modular, for example, offshore oil, I mean, they really, to get those things also commercially viable, they find really good ways of modularizing things. And I think this is what we also need to do with the small modular reactors. We'll get it eventually.
Thank you very much, Francis. Please a round of applause for Francis.
Thank you.
Thank you. So, please welcome with me our stakeholder from Tanzania, Professor Lazaro Busagala, the Director General of Tanzania Atomic Energy Board. Tanzania Atomic Energy Commission, sorry. Welcome, Professor.
Thank you so much for this opportunity and for introducing me. I'm waiting for my presentation. Yeah, thank you. I'll be talking about Tanzania nuclear activities updates. Currently in Tanzania, we have no nuclear power plant yet, though our policy indicates that that's one of our energy mix option. And because of that, I'll talk much of the capacity building that we are making and the things that can follow afterwards. This is the short, the outline of my presentation, whereby I'll talk about the establishment of Tanzania Atomic Energy Commission, then the nuclear capacity buildings that we are doing, and current energy sources in Tanzania, and the consideration of the policy and some few challenges that I'll mention. But before that, it's good to remind some of you, because sometimes you might ask, some people ask where Tanzania is. So I've tried to show you where Tanzania is and how spacious it is, as you can see indicated in the presentation. And those are our neighbors that we have mentioned. And many of them already, they have made the decision already to go for nuclear power. And the Tanzania Atomic Energy Commission was established in 2003, and with two main mandates: to regulate and promote at the same time. And this replaced the National Radiation Commission that was established by the Protection from Radiation Act of 1983. And this happened when we did join the IEA in 1976, as some progressive work has been done in which capacity building essentially has been taking place. First of all, to have the nuclear law was a progress, but before that we have only the radiation protection law, and it has a number of regulations to that effect. Now, capacity building projects that we are doing in Tanzania, and I'm just covering from 2018 to date and leaving out the history. That currently Tanzania Atomic Energy Commission has expanded to 6 zones and 1 country office, which is in Zanzibar, whereby, because Tanzania is the United Republic of 2 countries. One is Zanzibar and the other is Tanganyika, then you get Tanzania. So the act is a union matter, and for that case we have now zone offices whereby previously we didn't have. And 2, the number of staff is growing in the country, and currently we have 6 nuclear power plant engineers who have been trained in various universities around the world. And you can see that we have made slowly but progress from when we began from 10 staff. Now we are more than 208. Because of this also we have introduced training programs whereby the government pays for our staff, and in the first training program that ended 2022, we trained in 29 staff in different levels, including diplomas, bachelor, masters, and the doctoral degrees. And currently we are having a training program, and 32 staff expected to be trained in various areas of fields, and that's paid by the government 100%. And from this July, we are beginning to send at least 5 non-staff, provided that they are just Tanzanians, using the Samia Suluhu Hassan scholarship. Samia Suluhu Hassan is our president, has introduced scholarships whereby we'll be sending them to various countries where the nuclear power plant and in various specialties that they are advanced than we are. And this has been approved and it has been launched already. So we are going just to start implementing, and the budget for that is already allocated, and the government is going to pay for it instead of depending on aid from outside Tanzania. And we also participate in, we have also established master's programs at at Nelson Mandela Institute of Science and Technology, whereby health physics and radiation protection is being offered. And this is going to help us a lot for regulatory, for the regulators to get staff. And in that purpose, then if we go for any nuclear application, it will be possible to do the regulatory functions without problems. We also noted that we have challenges on TVET training, and therefore 6 curricula has been approved by the regulator, and now we are in the preparation to start running them so that we can get technicians of different machines and facilities that we are going to be running for nuclear related purposes. And this capacity building on the building projects or construction projects, and I don't want to dwell much on this, but we are just saying that we are building laboratories in which also we are building capacity to do the regulatory and the promotional functions, including the nuclear instrumentation laboratory, which is included in the laboratories that we are building. And all these have been already, actually they have been completed already, most of them, except in number 4, where also we are building irradiation facility in the former capital, Dar es Salaam. And doing so, we are confident that in the near future, our capacity will increase. This is the one of the laboratory complex in Arusha, where we have just completed constructing and where the Tanzania Atomic Energy College will be hosted. And this is the other side of the same building, and this one as well, and that one. And for irradiation facility in Dar es Salaam, currently we are about to complete the laboratory that will be related to irradiation purposes, and the bunkers are going to be constructed soon because we have already the contractor on the site, and all the logistics that will come in for that will be done accordingly. Now, energy sources and the consideration for nuclear energy in Tanzania. Currently, these are the energy sources that we are having. mainly hydro, natural gas, fuel a bit, which takes the size of 4.3%, and the biomass. We are confident that hydro power is going to take a bigger share soon because we have a bigger project that we are completing to construct now in the country. And this is the project which will give us 2,015 megawatts of electricity. So it was a great indulgence to this, and we know that the future demands more of these. So we are considering to go for nuclear power after that project. The national policy, as I did mention from the beginning, recognizes nuclear energy as one of our energy mix plan, and various teams now from Tanzania Atomic Energy Commission and the Tanzania Electric Supply Company are meeting frequently so that they can put up a concept note to initiate the process in the government for decision making. So if this will be decided, then we are hoping that soon the stakeholders and the partners that we have met in this forum will be very crucial to work together so that we can make our nuclear power plant program a success. And the challenges, one, I don't know if this is common to all countries, but in our country there is inadequate awareness of atomic energy applications among the public members. The solution to this, we continue with the effort to ensure that people understand what we are talking about. Because even when you say, for example, this chat is on the internet, and when you tell people that we want nuclear power, the first thing comes in their mind is you are talking about nuclear weapons and the bombs of such nature. So we are trying to use this figure to ensure that they understand. And number two, inadequate information and experience in the country whereby developing nuclear energy projects could be smooth. For example, one of the questions which is interesting to most of leaders in the country, if we could have gone for nuclear energy, how cheap could it be compared to the hydropower project that we are constructing now? How comparable? How about the running cost? And how much will the client pay? So when you try to search for any information on this, the information is not usually readily available. So I consider it to be a challenge. I believe as we continue interacting together, we'll come up with real information. So I thank you so much for inviting us to join this conference. And for that case, we believe that we have done a number of networking with the different stakeholders in the nuclear business platform. And for that case, our consideration for nuclear power plant can be easily implemented. Thank you so much for listening.
Thank you very much, Professor. Any questions for Professor? I think it was crystal clear, so no need to, yes.
I think the most clear presentation. Thank you.
Exactly. Thank you very much, Professor. I know there is just one presentation standing between you and lunch, so we will go straight to it. So please welcome with me Professor Seth Kofi Debrah, Director, Nuclear Power Institute from Ghana Atomic Energy Commission.
Thank you very
Seth.
much. Okay. Okay, so thank you very much, Ibrahim, and good afternoon. I think every time you put me in a very tight spot. Yesterday was between people going for their breakfast and the signing ceremony, and today is people going for lunch and a presentation. But I think it will be interesting to look at this. And this will be my introduction. It's a quote by Ken Robinson. And it says that human resources are like natural resources. They are often buried very deep. And you have to go looking for them. Usually they are not just lying around. But you need to create the circumstances or the environment for them to show themselves. And that's how I see human resources as. Somebody needs to build them. Somebody has to spend the money, the time, the resources, create the enabling environment for them to grow. Usually people poach, and they poach already polished human resource. I think it's harder to build than just to poach and use. And once you build, that person now grows with whatever organization that person is in. And this is how I define capability and competencies. Always, when we talk about human resource, our minds are adverted to only that person we are developing. But there is a component. Is this thing working? It looks like it's working, but okay. There is a component that has to do with the institution that's involved. The institution has to provide the resources to build that human capacity. It has to get the authority, the authorization from a higher level to have that human capacity in place. It needs processes, and usually we forget about this. And this has to do with management systems that needs to be in place, that needs to be established for that human resource to progress. Do things in a certain way. And this is quite important to the nuclear industry. It needs to have the equipment. If for a research institution, it needs to be a lab. A well-equipped lab, let me put it that way. There needs to be a means of deployment. How is the person supposed to be deployed? Are there structures, are there systems set in place for the person to be deployed? But when it comes to the person, we talk about the competence of the person. So we are talking about the knowledge base, the skill, the attitude. What happened? The skill, the attitude of the person, which is key. In Ghana, this is our educational system. The blue or the shaded parts are what we are seeking to do. You have the other shaded parts in other colors that also we are seeking to do. So we have the basic education, basic school, that usually when you are out of basic school, you are about 15 years, except you didn't start school early, like myself. And then you go through the senior high school. There is a covert program, but it's not nuclear related. There's a skill development up to a certain level of expertise. And then you go through the technical universities, you come out as a graduate. But this is what we are seeking to do. We want to add what we call a covert apprenticeship program, Commission of Technical and Vocational Education and Training program that is geared towards building the capacity or the competency of the people. So after basic school, you can go through this or you can go through that, giving the option for people that are naturally skilled. The skill development is not for everybody. It's not for all. Some people are naturally good at electronics, good at welding, good at computers. If you give me a computer, you want me to work on it, you are not going to get any results. That is not my passion. But people have passion for it. We need to give that pathway And we want to create an engineering school at the School of Nuclear and Allied Sciences that focus on engineering. And I'm not just talking about nuclear engineering, all aspects of engineering, but fused with nuclear education. We want to have a higher national degree program. In this country, higher national degree have been collapsed. We need to bring it back. That's the middle level management, middle level people that we need. Hands-on. And we need to start introducing industrial training. You have people who have finished school, they are graduates, but they have no industrial training. They don't understand the industry. So you go in and then you start learning. You are not productive till about 3-4 years. We need to start integrating the people into such things. So yesterday we spoke about this. I think one of the panelists spoke about this. And you can see nuclear engineering degree is about 10% of the total number of people you need. So when we move out and people are talking about, yes, we need to train people, PhD, masters, beautiful. In nuclear engineering, beautiful. But where are they going to go? Have we thought about it? We are creating pipelines that are not going to have work to do. We need to start developing people in chemistry, biology, physics, the other engineering disciplines, engineering, the electrical engineering, civil engineering, geodetic, geomatic engineering, but infuse nuclear into it. How let them have that nuclear background? And unfortunately, I know we have other institutions here, research institutions, that are helping build the capacity, the competence of the institution and the people. But when you look here, the people who work in the nuclear industry, please show me which one have a PhD and a master's. This is what we are missing. We are missing the mark in Africa. We are not talking about, I have a PhD. Forgive me if you have a PhD. Have a PhD. We think in a certain format. We are more research oriented. That's what tickles us. This is not research. This is business. You need to give the people a certain skill set for them to do. So you don't see PhDs and masters over here. You see a 4-year degree, a 2-year associate degree. Sometimes welding, 2-year welding, high national diploma degree. I've met so many experts, let me put it that way, who have worked in the industry for years, but don't have a master's degree, they don't have a PhD. They are not professors. But they are working in this industry, making it work. You can ask Laurent, how many PhDs do you have at EDF? You don't. You can ask the CNNC, ask NewScale, ask the vendors here, how many? And we are so focused on churning out PhDs and masters. I'm not saying it's bad, but we need to reorient ourselves as a people. I'm not just talking about Ghana, I'm talking about Africa. We are not just talking about providing or producing those people just for the nuclear power plant. There are other industries that we need to provide those services to. In terms of human resource, we need to build capacity for. You will have engineering companies that will provide technical support services. They need to understand the technology. They need to understand the terrain. Manufacturing companies, civil construction and system assembly companies, services. This is my favorite part because this is where the food is. If in the industry, there is a standard that you need to follow for food preparation, because we don't want you to give us food poisoning. You need to train these people. I'm not just talking about the nuclear power plants. I'm talking about other services that's around the nuclear power plant. We need people to do some research. But in doing this, we need to also work with the private companies. One key thing, policymakers, we always forget them till we hit a snag. The policymakers must understand what we are doing. How are we getting them along? As I speak to you, we have 2 policymakers in Vienna on contract specifications to make sure they fully understand what we mean when we talk about contracting a nuclear power plant. It's not a one-day job. It's not like procuring solar power plants. Forgive me if you are a solar person here. It's a unique environment that you need to acquaint yourself with. That policy now needs to make technology to make sure that the project happens. So we have national HRD plans, and the success of it will depend on our HRD strategy, policies. We already know education is critical, but we need a roadmap. A roadmap that is not a 2-year roadmap, a 5-year roadmap, but a 100-year roadmap that is continuously reviewed and updated. Because things change, knowledge change, and we need to inculcate that into our roadmap. For education structures, we need qualified people. But how do we qualify them? We have tertiary institutions that we're working with. What are we doing with our tertiary institutions? We have the Kwame Nkrumah University of Science and Technology. I'm talking to the Ghanaians now. We have institutions like University of Ghana, the biggest university where I graduated or had my second degree from, and my PhD from, of course. How are we engaging them? We have public universities all over this country and all over Africa. How are we engaging them? If we don't take care, there will be a time where we will be ready to go to them, but the program would have already been delayed because we have not engaged them early enough to give us the kind of people that we want for a project like a nuclear power plant. We need to go into crafts. Some of the Ghanaians here, or most of them here, will tell you, if a tailor, a seamstress, a fashion designer sews something for you, like a dress, and you don't get a very good one, by the time you raise your hand, your armpit is already showing. Why? Because it gives way. There are no standards. People are not trained to do things in a certain way. You lay tiles, 1 year the tiles have started coming off. Because we don't train our critical staff, the craftsmen. We always leave them out of our programs. And something that is quite important. So culverts already established, but we need to upgrade them. We need to get them to that level where they can play part in our program. So we have institutions that play a part in training. And usually in most countries, you have the research institutions playing that role. In Ghana, it's the Ghana Atomic Energy Commission. We need to upgrade it. It's a project that needs to go on. And not just upgrade, but the commission must be able to handle the maintenance of the equipment that is being put in their hands, to train people, to do the research. We need to establish national and international cooperation to bridge capacity gap. That's why we work with China, Russia, France, US, South Korea. We work with everybody. We need a well-developed research and training institution with private participation. Why? Somebody will say the training institution, well, the research institution can play that role on their own. But research institutions are not meant to turn profits. They are not business-oriented. Again, nuclear power plant operation is business-oriented. We are not talking just about research. The research feeds into the business, and they need to learn how to do that. The best way to do it is to actually integrate private sector into it. But what are our challenges? Number one, we need a comprehensive nuclear education. That's being worked on. Number two, there needs to be a training program. And you can see, we've split education and training because they are two different things. Two different things. You having a degree, you sitting in the classroom for us to impact is different from you doing. The Ghanaians here will tell you, I don't know about other African countries because I've not attended school in other African countries. You finish school, you go into an organization, and whatever you have learned is not used in that organization. Maybe it's just me. Maybe it's just me. Maybe you have not experienced it. But this is the real facts. The things that are taught in class are not applicable on the field, are not applicable in the industry. How do we bridge that? That's why we are talking about 1 year internship in the industry. So that we are able to link the people that are coming out to the industry. By the time he finished or they finish that 1 year, 2 year apprenticeship, he will be ready for the market. He will have a certain level of skill development. We need to establish facility upgrade. I've already talked about the Ghana Atomic Energy Commission. We need to equip and then maintain teaching and learning. Issue of mentorship. You go to our schools, especially our universities across the globe, and there is no established mentorship program. So a professor leaves, a doctor leaves, a professional leaves, and there is a huge gap that we need to fill. All of a sudden, everything comes to a stop. Where are the mentorship programs? Where are the leadership programs? That's what we need to do as a continent. Again, we need to have transfer of knowledge. I know in some institutions when somebody starts their work, I don't know if, well, I'm very current. As I told you, I'm young. So I went to a school from class 1 to class 6, secondary school, university. From class 1 to class 6, through secondary school, there is this person who is always first in the class. When he starts doing his test, what does he do? He will cover everything like this. It grows into, I'm not saying cheating is good, but there's a certain mentality that they grow up with. They get to the highest level and they hide everything in terms of their research. There's nobody who is attached to the research. Nobody. So when he leaves with data and everything is gone. We need to share knowledge. We need to find a platform where we can share knowledge. We need a recruitment strategy. How do we recruit people? Based on who we know? Or based on meritocracy? The person we are giving the job to, does the person merit it? Has he shown enough finesse for that job? We need research and development in energy. It's key. Again, yes, sir. You have paused my presentation. What's happening? For strategy for HR development, we have couched something, and it's compartmentalized. So you can have the owner-operator that works with the vendor country, the APC contractor, the vendor country TSO. It works with the vendor education and training institute. It also works with the IEA. When local education and training, we are talking about education and training institutions, IEA, and other established nuclear institutions. When we talk about industries, we are talking about regulators. We are talking about the country industries or the vendor country industries, because they have the technology, they have the know-how. You need to integrate your industry into their industries, or they have to integrate their industry into our industries. In Ghana, we have what we call local participation. It's a law. So if you are bringing in money, you are bringing in that technology, you need to actually also meet that law. There's a certain percentage of localization, minimum, that you have to do. So you need to find industries here and integrate them into your industries, or the other way around. Regulatory bodies, you have the vendor regulatory bodies, or interacting with them, and also the IEA, and TSOs, again, same, the vendor country. So you can see that for a newcomer country, there is heavy reliance on the vendor country. Why? This is the first time we are doing it. We don't know how to do it. So you need to learn. It's key. So for Ghana, this is how we, and this is kind of sums up our strategy. This is our approach. You can go into it if, need be. We need to start upgrading our existing postgraduate education. Start short courses. There are engineers, biomedical engineers, electrical, civil, whatever engineers, that are willing to undertake short courses to upgrade their knowledge in the nuclear field. So we've sectioned it into phases, and that was our approach to this whole thing. So some key takeaways before we go for lunch. We say this: the success and sustainability of a mega project, and nuclear is a mega project, whether an SMR or a large power plant, is a mega project. It will require the flow of human resource throughout the cycle, the life cycle. So from the cradle to the grave, you need an education and training that should be critical to the skill development, the knowledge acquisition, the attitude development, and the skill development. As we say, once the human capital is developed, there should be the need to build the institutions that have the capability to support and sustain the project. And that's why you have the NRA established. You have the Nuclear Power Ghana established. You have the GMPP established. You have other organizations that are established to actually support this nuclear approach. Thank you very much.
Thank you very much, Seth. Any question for Seth?
Thank you. Prof, what you've just given us is quite comprehensive, but in terms of leadership, who is supposed to push this? Is it political? Is it from the industry? Is it putting it in the curricula of our education system? Whose responsibility will it be to push this in terms of leadership? Thank you.
Thank you very much. That's Lawyer Joshua, for those who doesn't know. He has a beard like myself. So, in terms of leadership comes at various levels. So when you go to the owner-operator company, they have a leadership, I will call it scheme, and it needs to flow from the top. But the program itself needs a leadership, because everything that happens, whether regulatory, whether owner-operator company, whether vendor, whatever, it flows from the top. So we need government to bear on the program, provide that leadership for the program. Once the government bears on the program through its leadership, the others won't have an option but to follow. Because if I'm forming the owner-operator company, what I'm doing is what the owner-operator company is actually following. It becomes a culture. So you need that high-level leadership from governments, from the NEPU, from the, well, in Ghana we call it the GNPPO, from the NEPU to provide that leadership for us to actually move. Because technically, nuclear, whether we like it or not, people say we shouldn't politicize it. Nuclear is politics. Nuclear is politics. Whether is it geopolitical or national, it's politics. And that's how come we don't leave it in the hands of technocrats to say whether we are going nuclear or not. It's heavy. So once it's that heavy and it sits at the political realm needs to provide that leadership for us to go.
Indeed, thanks, Seth. Any other question?
Very short. Yeah, I'm just adding my voice to a short contribution to the statement you just made that nuclear is politics. To tell you the truth, all the analysis people have made into the problem of nuclear power deployment is the failure of the nuclear industry to position itself to make it attractive to the politicians and the public. And if we don't strategize along that line, issues of the stagnations and whatnots we are going through will continue. So let us think also along that line. How do we package nuclear in a manner to make it politically attractive? In fact, all the renewables and the rest, all that they are doing is to make it politically attractive. Thank you very much.
We had that question over there.
Yeah, thank you very much. It's not a question really, but you are training people to fit into the nuclear organization, a nuclear power plant. But we don't have a nuclear power plant. You are training doctors, nurses, and there's no hospital. So what do we do? The head of AFCON was here. He was suggesting that maybe we should pool resources in West Africa and build a common nuclear power plant to serve our needs. Maybe it is time for the regional considerations, East Africa, West Africa, and so on, and interlink the grids and so on, so that at least if we are united in this, something can come into being. The second aspect is that if you train people and there are no facilities for them to get an experience, can't we have bilateral, contracts or relations with other countries where there are nuclear facilities? So after training, they go on attachment there until we have our own plants, and then they come back. Otherwise, they stay here frustrated, and they are not happy with living conditions or salary and so on. But these are just ideas for consideration. Thank you very much.
Thank you. Let me just touch quickly on the issue of the regional approach. Regional approach is always good. And that's what I've come to learn. But it gets to a certain point where it doesn't work. Because every country in that region has its own sovereignty. It has its own issues. You talk about grid. The West African Economic Bloc is actually connected via the grid. we have issues with some countries in terms of fluctuation, in terms of frequency modulation. So we have that connection. But coming together to buy one bicycle for all of us to ride is always a challenge. Because you will want, if you are a country, you will want your people who are in the country that the plant resides to have more influence in terms of work. Okay? If it happens in the unlikely case of an accident, your people will suffer most. So you want to get the most benefit out of it. What I believe is this. A country or two may lead and use the grid as a wheel to other countries. But coming together to buy one bicycle to ride, you have 7 countries. We are all Africans here. Well, we have some colleagues over here. We know it's not a hidden fact. It's actually an open secret that some of our colonial leaders or former colonial leaders, masters, still have a handle on some of the countries. Unless we are just burying our head in the sand. I will say it as it is. They still have a handle on some of those countries and tell them what to do, when to do it. So even our ECO, that currency we are trying to establish, is not even working. When were we supposed to launch ECO? A long time ago. How much more do you think we can establish a nuclear power plant together? It's going to take forever. By that time, Christ has come and then we are all dead. So,
thanks. Thank you very much, Seth. We have time for one last question, if there is any last question. Yes, but basically, thank you very much, Seth. And basically, as we are on the human resource development, so we will have one last presentation before we go to lunch. Sorry, I give you a false promise before. So one last presentation, and then we will go to lunch, but it's on the same topic. So I would like to call and welcome with me Michael Shatlani, Vice President of Business Development, Power System and Simulation from H3 Canada. Please, a round of applause.
Tanzania and Ghana views on human resource development, and that is exactly what I'm here to talk about. I'm Michael Shatlani. I'm the Vice President of Business Development at L3 Harris in Canada, and I'm talking about what it says on the slide, making nuclear learning better, and our approach to it. Before I do that, since I'm here from Canada, I'm going to brief you a little bit on what's happening in the Canadian nuclear landscape, a little bit on our business, and why we're going in this direction with this nuclear training program called Nuclear in 21. So, in Canada, we have 3 nuclear operators, Ontario Power Generation, Bruce Power, and New Brunswick Power. 2 of them, OPG and Bruce Power, are in the province of Ontario, our most populous province. And 1 is in New Brunswick, which is a very small province, less than 1 million people in that province. They're all using something called the CANDU, a pressurized heavy water reactor technology, which is a Canadian-developed nuclear reactor. You can see some pictures there. We have a very strong supply chain for the size of country we are, for the size of nuclear program that we have. We have about 250 companies, 76,000 jobs within those companies. Canada is going through a major revival of its nuclear program. So right now, we are refurbishing the Darlington sites and the Bruce sites. When you refurbish a CANDU reactor, it's a big job. These are 2 of the biggest infrastructure projects in Canada right now. And they are proceeding on time, on budget, which is a nice thing to hear in our industry. right? We're performing really well. The supply chain is set up really well. All of this work in refurbishing the reactors also gives us license to build new reactors. And it sets our industry up to be able to do that. And that is what is happening. Just earlier this year, the government of Ontario announced that we would be refurbishing the reactors at Pickering B as well. So that's in Ontario as well, 4 more units. They were planned to be shut down in 2025. In the province of Quebec, we have one shut down reactor called Gentilly. The government is secretly studying reviving it. And we also have Canadian CANDU reactors outside of Canada in Argentina, China, Romania, and South Korea. Speaking of Romania, the government has just committed 3 billion Canadian dollars, around $2.2 billion, to building 2 more CANDU reactors at Târnăvoda site in Romania. So the opportunity is large. 2-3 years ago, you couldn't get our federal government to say the N-word, nuclear, right? It is openly spoken about now. Policies are set up to allow nuclear to happen in Canada now. Canada now understands the importance of nuclear for our climate change goals, for our energy security goals. So the opportunity is large. In Ontario alone, they have estimated that we need to double capacity by adding 42 gigawatts electric. So right now for Ontario, we're estimating 20 large reactors, 45 SMRs. In terms of large-scale nuclear, the government of Ontario has already announced that we will build 4,800, up to 4,800 megawatts more of nuclear at the Bruce site. So right now we have Bruce A and Bruce B, and we're going to build Bruce C. The local company that is the steward of the CANDU technology is called Atkins Realis. During the World Nuclear Exhibition, they have announced that we are rolling out a Generation 3 Plus 1,000 megawatt version of the CANDU reactor. So that's exciting times happening. It's a great time to be in the nuclear industry. Now, you may or may not know this. American Westinghouse company is also owned by 2 Canadian companies, Cameco Corporation, our uranium producer, and Brookfield, an asset management company. So there's a lot going on in the large nuclear space, but also in the small modular reactor space. So Canada's been very interested and taking a leading role in the rollout of SMRs. Natural Resources Canada, our Ministry of Energy, has issued a roadmap in 2018 and an action plan in 2020. And the Canadian Nuclear Safety Commission, our regulator, is performing pre-licensing vendor design reviews on 9 of the SMR developers' technologies as we speak. Global First Power, a joint venture between one of the reactor developers and Ontario Power Generation, is developing the first micro-modular reactor, so a really small unit, at the Chalk River site in Ontario. And Ontario Power Generation has already signed contracts to build 4 grid-scale reactors, small modular reactors, at the Darlington site again. And they have selected GE Hitachi with the BWRX 300 design. Like many other nations, which is fantastic, Canada has signed up to triple nuclear power, nuclear energy by 2050. And now we move on. So that's just a very brief overview of what's happening in Canada. There's a lot going on. About my company, on the right-hand side, I'm from a company called L3 Harris Maps. We take care of 3 business areas, nuclear, naval, and space. In all of those businesses, we do automation and we do training and simulation. We are a subsidiary of American giant L3Harris Technologies based in Florida, and you can see why I say giant. We're about 50,000 people with business in about 100 countries and revenues of $19 billion. Diving right into the power business, we have been in the power business for some 51 years now. Our work started with, of course, programs in Canada, expanded in the United States, and then we went all over the place. Our simulation and training services are not targeted at one special design or one specific technology. As you can see, we do programs for CANDU, PWR, BWR, gas-cooled reactors, and we've recently done a molten salt reactor. And we've dabbled in some non-nuclear work as well. Our portfolio from left to right, maybe, technologies and training services to make the classroom and technology environment good in the classroom. Operator training simulators, that is to train the operators and to license the operators. We also do simulation assisted engineering that is largely used by developers to validate their designs, to test their designs. On the far right-hand side, you're looking at digital twins, 3D digital twins, I should say, where we are interested in reproducing entire facilities and making them work. It's not just a reproduction where you can take measurements and so forth. So we make them work by attaching them to simulation, by attaching them to the live plant. And then at the bottom in the blue box, we also produce the plant computers for the Canadian nuclear power plants. So jumping into training now, you know, the cost of an operating unit is a lot of money. About half of that is the personnel needed to run that unit. And I know the SMR vendors are working on finding that optimal balance, getting the head counts down, but it's still a significant piece of the overall cost of the asset. Now, training in the nuclear industry is fantastic. It is based on a very systematic approach to training. It's not going to go anywhere. We're going to keep training like this for a long, long time. But demographics have been changing in recent years. In the West, we've seen a lot of attrition. People look more like me and they're retiring. New builds are coming. And new builds are coming for you, Bob, and for everybody. There's a lot of business that's going to happen in the nuclear industry. I have no doubt about that. And we're going to need a lot more people. But we have been teaching fundamental systems, everything, in a certain way for a very long time because we haven't really built new reactors for such a long time. It's coming now. So, but that systematic approach to training has led to very good program design and different things that are used as part of those programs. And what we're saying is that those programs need to be modernized. And we're not alone in this, right? The thinking is changing. On the right-hand side, you see a document that was put out by the Institute of Nuclear Power Operations that says we need to change the way we approach training. And so that's exactly what we're doing. We're making the training interesting, more engaging for the younger learners, and quite frankly, for the older learners too. So the foundation for all of this is when you see something, you understand it better, and when you interact with something, it helps you remember, right? These are basic principles. I don't think I have to convince you that this is the case. But imagination is subjective. When an instructor is going through a big pile of drawings and saying the flow goes this way, and then he shows you a flow going another way, and he's expecting you to understand that, that's a long and hard learning curve. So we introduced Nuke Learn 21 last year in Kampala. And what it is a technical training program for pre-operations, facility maintenance, and radiation protection. It's a technology-enabled training program to the largest extent possible. We're very much advocates of innovation and technology being used to make life better. So everything that we do in these programs is make it easier to understand, make it easier to interact, and view what you're understanding. So modernized learning environment for better student engagement. And we're covering all the way from the basics to pre-operations and maintenance. So we're kind of filling a gap between sort of all those workshops that you do in the early stage and when you're actually running a nuclear facility. The program is also designed to be put in the customer country. And I'll talk more about that. What it's not these short courses that Seth mentioned or workshops. It's not a university program for nuclear science. It is not a program that's specially designed for future regulators. And it's not a leadership or communications program. It's not a, wow, I'm unselling myself. It's not a program for turning bolts and doing welding. It's not an overseas training program, but it can be. So it's a comprehensive program it's a well-designed program that has three major components in it, what we call the nuclear candidate program, radiation controls, and facility maintenance program. It has about 120 lessons in this overall program. It's not a small workshop. We provide instructor guides, study guides linked to the technology, and the technology is quite extensive, and I'll show you a little bit of that shortly. We will provide the seasoned instructors that come into your country and deploy that training for you. So this is what I was talking about before, right? That old training material that we have, it's good, it makes sense. It looks like this, maybe a little bit better than this across the top, right? And our view is, why make the students imagine all that stuff? The technology has come further than where the training programs are. Let's capitalize on that technology. So we've introduced a series of technologies that are made available not only to the instructors, but to the students as well, so that they can engage, because we think that engagement piece is very important. So an example is when we're down in the fundamentals level, or we're looking at mechanical components, we have all kinds of modules that are available to, again, the instructor and the students. And they should be able to visualize what this thing does, and they should be able to visualize the major components in that item. So there's many of these different components, starting from the basic. When you look at a 2D cutaway diagram, I've done it. I have no shame in admitting it. Looking at a 2D diagram, not knowing if it's actually round or if it's square or whatever, right? You're nodding your head. You've done it too. Yeah, so that's what happens. That's what this is very low-hanging, easy to deploy technology. Now it gets more complex, right? Do we want to learn about this air-cooled breaker using this? And the instructor is trying to get you to understand all the things that this breaker does using that. Or do we want to do it this way, right? I think it's kind of obvious what the answer should be. Now, as I said, this technology is not just technology. It's embedded in the courseware so that even on the student workstations, they can go from their course guides, open up the items that they're looking at, and understand what it's doing. Now we've understood the components, we've understood the basics in nuclear. Now we need to understand the various systems in a nuclear power plant, right? Do we again do that with the old way, with lots of big drawings and going through flow paths and so forth? Or do we put these small simulations in the hands of the students and let them operate it, let them see what the consequences of their actions are? Now that we've understood the various systems in a plant, we start understanding what is a plant. You know, people talk a lot about simulators. We heard about that great announcement yesterday from NewScale and the training simulator being put up. But what if we had something called learning simulators, where we understand not the operating procedures, but we understand the physics in that nuclear power plant, right? What if we understand all those different evolutions that happen in a nuclear power plant by seeing those evolutions? So we have created technology for that as well. As part of our program, we also bring simulators as part of the program. Full-scale simulator in a separate room, and within the classrooms, we introduce a classroom simulator as well, so that the instructor can take small groups and show them what he's talking about there and then. So when we introduced this program last year in Kampala, it was called Nuclear in 21. We've just rebranded it to the Nuclear in 21 Advanced program, because it's a big program, right? And we got some feedback from some of the countries that we've spoken to in the African continent. And a couple of them were interested in seeing something a little bit smaller to get started. So what we've been doing recently is we've introduced a basic version of that program. And what you can see is if you compare those two boxes, we've reduced the technology stack that's available in the basic program, and we've also reduced the courseware set, the number of courses in that basic program. But the same principles in both, and the basic program can be used as a bridge to get to the advanced program. So in summary, and is it good timing? Yeah? In summary, it's a comprehensive technology-enabled learning program that we've now split into a basic and advanced. It takes advantage of easy-to-understand technology that is built into the courseware. And we will provide that first-time in-country training service led by seasoned instructors. And then we will train the trainer and let you guys take the program over from us. Thank you very much.
Thank you very much, Michael. So we will open the floor for questions. Any questions for Michael?
Thank you. Mine is more educative. On one of your slides, you had 3 pictures of, and I'm not sure whether it's the feedstock. You had molten salt, terrestrial, and all that. Could you explain that to us?
Oh,
the feedstock.
Tell me where.
I think go further. One of your earlier slides with 3 pictures at the side. No, it's none of the diagrams. Just keep going to your first bit.
Oh, maybe towards the beginning, right?
Yes, towards the beginning.
I don't remember anything on molten salt being in this presentation, but I can talk.
But it was on the side. You have 3 different pictures on the side.
This one, yes.
No, not this one. I think it's before this one. Next. This one.
Oh, you're the picture over there on the right. Yeah.
So you have molten salt reactor, liquid sodium reactor, and high temperature gas reactor. What's the difference? And out of these 3, which would do for Africa, if those are feedstocks for them?
Sorry, what are the difference between the 3? And?
Yes, and which of these 3, if it is feedstock for the reactors, which would do for Africa?
I don't know how to answer the second question. The first question is that I chose these particular pictures because there's a Canadian element to them, since I was talking about Canada. The IMSR plant is a molten salt reactor. Huh? Oh, what's a molten salt reactor? It's a... Where's the gentleman for dual fluid? Is he here? Oh, there he is. Do you want to describe what a molten salt reactor is? And then I'll give you the easy version.
So molten salt reactor has been developed by Alvin Weinberg in the 1960s in the US, and it worked for a couple of years nicely, but was shut down for whatsoever reasons, economic, in the US administration. The thing is, with molten salt reactors, they use liquid fuel instead of fuel rods, or solid fuels. And liquid fuels have a very superior feature in they have a very strong negative temperature gradient. So if there's a local power excursion in the reactor, the liquid expands, and the expansion is enough to slow down the nuclear fission reaction efficiently. And there's a number of molten salt reactors out there with thermal spectrum and fast spectrum, so that is not a discriminator. I don't want to go too much into the details here. Dual fluid actually is a further development from the molten salt reactor. We use liquid metallic fuel, so nearly pure uranium and lead as a coolant, and that's because in molten salt reactors the liquid fulfills two functions. That is the fission reaction and the transportation of the heat, so to make it usable. And salt is not the best heat conductor, as you know. So we will, or in our design, we split these functions on two different specialized liquids, and the molten salt reactor just does it in one set, and it comes at a cost of huge size. So you have to dilute the fuel in the molten salt liquid, so you get large structures.
Thank you.
Thanks.
So, in the case of the IMSR plant from terrestrial energy, it is, like Bjorn mentioned, a liquid fuel that moves through salt. It creates high temperature that can be used, and this is the target markets, not only for electricity, but for other applications, industrial applications, because you're getting high heat out of the plant. The liquid sodium reactor on the right uses, on the second picture, uses liquid sodium for cooling, but if I remember correctly, it has a solid fuel with enriched uranium. And then the high temperature gas reactor, as it describes, is a gas-cooled reactor. And very small. So this one originally was going to be around 5 megawatts electric. The company decided to change the design earlier this year to a 15 megawatt electric design. And in Canada, why we're considering such small reactors as well is we have many remote communities that are not connected to our grid, or they're powered solely by diesel. Diesel has become very, very expensive to get the diesel over to those remote communities. So that's why we're considering small micro reactors of that size as well. So it depends on the geography. We want large, we want SMRs, we want what Canada calls VSMRs, very small modular reactors. So Canada's moving in the direction of all of them. Does that answer your question, sort of? Yeah,
Thanks, Michael. Any other question for Michael?
Yes, ma'am.
Thank you. So I wanted to know whether this training is just for operators, or regulators can also learn alongside, or there's a special training package for regulators.
That's a good question. There is no special package for regulators in our training program. Our training program is more technically oriented, more oriented towards maintenance workers, radiation protection workers. There are subjects in the early phase of the training that would be valuable to regulators, but it is not a program on, it's not a training program that covers safeguards and security and so forth. It is the technical basis of all of the nuclear facility. Thank you.
I guess no more questions for Michael. So thank you very much, Michael.
Thank you.
Apologies, lunch is not ready yet, so we will go ahead with our agenda. We would have Donald Hoffman, CEO and President of Excel Services Corporation, to give his presentation that he was going to give in the afternoon right now. And then after that, hopefully the lunch would be ready and we can all enjoy our lunch. Donald, please come in. Please, a round of applause.
Okay, I think most of you know me. It's a privilege and pleasure to get a chance to speak to you. I too apologize on behalf of the organizers who are struggling to try to figure out why lunch is not here and trying to figure out your schedule. And here you all sit with empty stomachs and they're probably making noises and you're like, oh God, I got to sit through another presentation while my stomach is empty. Okay, good. Boy, how happy am I to be in this situation. Thank you, Abram. So, you know, my colleague from the north who gave you such a great presentation earlier, you know, it's interesting. As I said, I'm president and CEO of Excel Services Corporation and the founder of the company in 1985. I have an SRO license on a commercial nuclear power plant along with an SRO license on a nuclear reactor on a submarine. And having gone through the chalkboard explanations, this stuff that L3 does is really impressive. I'm thinking, oh my God, maybe I would have really learned more. I don't know. I did my undergraduate work with a slide rule. So I didn't have, computers didn't really come into place until 1986, and that was a year after I started the company. We had a fax machine. We thought we were cool. But long story short, guys, I'm just going to quickly say a few things about me to set the stage of where we are. I've met with many of you, regulatory authorities, atomic energy commissions, and other organizers in your respective countries about your new nuclear build program. So I'm a former engineering officer and reactor operator on a nuclear submarine in the United States Nuclear Submarine Navy in the 1970s when we had a Cold War with the former Soviet Union. I worked under Admiral Rickover and trained, and it was an experience and a privilege. And then in late 79, I left the Navy. I went to work for the Nuclear Regulatory Commission, which is our regulatory authority in the United States. I've already told you that I was fortunate enough to be handed responsibility for licensing 26 plants with 2 licenses each in 5 years. At the end of that 5 years, I turned 35 years old. Most of the people that I was working for when I got there were now working for me. It wasn't a real good situation. So I went out and started a consulting firm. The company will be 40 years old next year. I just turned 74 last Sunday, and I'm going on 12. I behave like a child, but I'm passionate about what I do. I believe in this. I believe in the activities we're conducting, but more than that, ladies and gentlemen, I believe in Africa. Whereas a lot of my U.S. colleagues don't think nuclear will happen in Africa, I do. And it's a privilege for me to be here with you, my brothers and my sisters, in the African approach to new nuclear. I believe nuclear can be very supportive to you. So in the last 35 years, and a lot of you have seen this brochure, we've established a number of programs and processes to support the current fleet. Power uprate, 24-month fuel cycle extension, design reconstitution, improved technical specifications, license renewal, subsequent license renewal, critical infrastructure protection, that's physical, cyber, and information security, and a number of other activities to enhance safety, improve performance, and reduce cost of operation. But in the last 2 decades, and this is more applicable to you, we've been spending a lot of time with new nuclear built countries, and we've seen what works and what doesn't. So because we're technology neutral, I use the word neutral instead of agnostic like my colleague from South Africa, we work with all the large, small, mini, and micro reactors. We know them all very well. We've developed design certifications, affirmations, licenses, other activities. So we know what's good and what's not so good. And they're not created equal. It doesn't mean any of them are bad. It just means they're not all created equal. So as we work in countries, and we've done this in 14 different countries, we've done technology selection. And that technology selection has been predicated on what did that country want? And this is what it's all about, you. And all the countries, all the nations in Africa that want new nuclear, what's best for you? What do you want to accomplish? What can we do to make sure you're successful so that all the global best practices, all the industry experiences, you don't get a chance to experience them either. So with all that in mind, we're working with setting up ministries, regulatory authorities, owner-operators in a number of different countries around the world. And what we want to do is to bring to you that experience and expertise, because you're smart, you're capable, you just haven't seen all this. What we want to do is to give you the experiences that we've already gone through in all activities so you're successful. So that sort of sets the stage for the four major things I'm going to talk to you about. What are some of the approaches that we're using, and what are the resource requirements? How can you be sure that your program will turn out the way you expect it to, the way you've committed to your boss, to your prime minister, to your parliament, to your stakeholders, that it will? So one of the first things we did was we said, okay, we've seen a lot of this. We've seen what ministries do. We've seen how they establish regulations and laws and interface with the other ministries. No countries are exactly the same. We work, as I said, in 29, and it's just unbelievably different. So sometimes there's a Ministry of Energy, a Ministry of Environment, a Ministry of Trade, a Ministry of the Interior, and they all have their own responsibilities. Sometimes it all goes into one ministry, but irrespective of how it does, there are ministries, regulators, owner-operators, and supply chains. So what we did was we developed a generic document for each one of those based on what we'd seen, so that when we go into a country, we can give it to the ministry and say, this is what you need to do. This is how you need to do it. This is who needs to do it. And this is the sequence and when it needs to be done to assure success, so that the ministry working with all the other governmental organizations can be assured that it won't do something that won't work well. So we're going to talk about that. The second one is rapid, efficient, and appropriate licensing approach. You see what's happening in licensing approaches. I'm going to talk to you about that and how we can make it easier for your regulatory authority to review and approve this. Regional consideration and construction's lesson learned. So with this, with our partner Jensen Hughes, who brings quite a uniqueness from risk-informed activities, because we wanted to give some risk insights of this, we created multiple roadmaps. We created a roadmap for the ministry, the regulator, the owner-operator, and the supply chain. So what do they incorporate? Our 4 decades of experience, hundreds of decades of our associates and employees' experience, reviews from former leaders from the Nuclear Regulatory Commission and the Canadian Nuclear Safety Commission, and significant input from the licensing engineers that were there when this was happening. Not just in the countries, but also at the nuclear facilities, to make sure that the generic guidance we're giving is the most efficient, the most effective, and assures you of a successful approach at the ministry, the regulator, and the owner-operator level. The supply chain is coming because we're trying to integrate that. So what are the roadmaps? The roadmap for each entity provides the who, what, and when of creating an entire program. So we create one for all the necessary actions of each one of those entities: ministry, regulatory authority, and owner-operator. And then this assures a successful, timely, and cost-effective approach. And then we do an integrated approach so that you can take one look and see who needs to do what and when. How the ministry supports the regulatory authority supports the owner-operator, the owner-operator supports the both of those, so that you're assured the most efficient and effective approach given what we've seen all over the world. And what we want to do, again, is to give you the benefits of all the global lessons learned, all the global experiences, so that when you start, the continent of Africa has the opportunity to start at the highest level possible, not back in and begin possibly recreating the wheel. So we've begun applying these processes in several countries, and they're working quite well. We're very pleased. We're making adjustments and changes based on experience, but again, that's the country specific. So the generic document really lays out how you might do it. Now, many of you are far along. You don't need that. What it might do is inform you, what am I missing? If anything, maybe you're not. How could I do this more efficiently than what I'm doing? Maybe there's ways. I don't know. So what we've been doing is talking to you over the course of the last day and a half to find out where you are, to get some sense, to sit down with you, to tell you the kinds of things this can help. The supply chain documents in final development. And the reason for that, in several countries, we're qualifying the local supply chain, making sure they meet NQA1 and other quality assurance requirements, ISO standards, how to make sure that there can be a local supply chain. If you're going to build new nuclear in your country, you have the right to develop your own industry, because nuclear is not just for developing electricity. As you know, SMRs can also do desalination, hydrogen production, process, industrial heat, district heating, and a number of other activities. But what it can also do is develop an industry in your respective country where you can decide what industries, what capabilities do we have, what things do we want to grow. You've heard people talk about welding, about piping, about construction, about electrical. There's so many things that you can get engaged in. Don't miss that opportunity. Every country has a right to have a localization aspect to it. So each generic process is modified to be country specific. So in several of you in here, whose name I won't mention, we sent this to you in a generic form. You gave us comments back. We modified it, came back. It became part of your strategic approach. And then the processes will be updated periodically. But what this enables you to do is to get ahead of the process and to figure out, how am I going to approach all this? Okay, so this is just the front cover page. I have some of these with me, but not as many as I thought I needed. So this is the one for ministries. And this is the one for regulatory bodies, and this is the one for owner-operators. And as I said, the supply chain one's in development. And these are only about 100 pages long right now, but what they do is lay out processes and mechanisms by which you can go forward. And so it gives you a place to start. Or even if you've already started, it gives you a place to check. So what's the next topic? That's the first one. Having been a regulator, having worked around the world and seeing the kinds of delays we're experiencing and the difficulties, when I talk to financing organizations, the two major things they tell me that concern them: licensing risk, construction risk. So we want to address those. If we're going to get financing for your companies, which I'm working to get, in fact, interestingly enough, where's my colleague from Canada? I managed to raise $6 billion. I wanted to buy Westinghouse. I wanted to make Westinghouse a U.S. company, and I wanted to change the way it does business, but I wasn't successful. Okay, next time. So what we're doing is we're finding ways to find financiers who want to be an integrated partner with you, who want to come into your country and invest in your activities. But they're concerned, as all financiers are. And the two major things, like I said, are licensing risk and construction risk. So let me talk about the licensing risk. How are we de-risking that process? You're going to purchase a technology. You're going to go through some kind of technology selection. You're going to down select. You're going to negotiate a contract with them. There's a lot of things to make sure that goes well. And I could spend hours up here, so I'm not going to. So before you do that, give us a chance to tell you the kinds of things you need to be concerned about, because not all contracts can be the same. We had the privilege to work with KH&P and KEPCO at United Arab Emirates to be a part of the activities. We did the technology selection. We helped them down select. We helped them negotiate the contracts behind the scenes. So we know some of you quite well. And we were successful in coming up with a good process where there was a certain amount of risk for everybody. And again, you should not have all the risk. So having said that, there are ways to make that happen. But in the licensing process, what we wanted to do is to take credit for what's already happened in that country to some extent. Now, what extent can that be? You're a regulatory authority in, pick it, Ghana, Kenya, Niger, Nigeria, Congo, wherever you want to be, Uganda. And now, for whatever reason, your owner-operator, your government selected technology X, which was licensed or design certified and may or may not already be built in country Y. What can you take credit for? How? Why? How do you know even where to begin? I was on CORDAIL, which is the Coordination of Reactor Design, Evaluation, and Licensing for the World Nuclear Association from 2007 in its inception to 2020, 13 years. did it for free, did it support, tried to give them input. I was the vice chair for the last 3 years. They could not come up with a process. So I said, fine, I'll create one. And that's what we've done. Excel works with too many countries and too many companies that provide nuclear reactor technology, large, small, mid, and micro, to not have a process we can all have confidence in. So what we developed was an approach. We didn't try to standardize regulations. We didn't try to standardize design, because that's not going to happen. A NuScale design looks different than a BWRX 300, looks different than an X-Energy, looks different than TerraPower, looks different than Holtec, and rightfully so. And there's nothing wrong with that. But how do you go about licensing it? So what we developed was a detailed step-by-step process that lays out how and what can you accept based on the country of origin review and why, what can you cannot accept and why as a regulatory authority, and what additional review must you do. So it gives you a guideline, gives you a starting point. And we're already starting to apply this in several places. It's not complete. It's about 90% complete. So I wrote it, had my staff look at it, and what we did was we had the former EDO from the Nuclear Regulatory Commission, the highest level, and the former president from CNSC, the highest level in Canada. We had those two regulatory authorities, previous leaders, review this process. Why? We wanted to see what would they accept and why. How did they think it would work? How would it work in Canada and then RC? And the reason that's important is that two technologies are going through that process right now in Canada, X-Energy and BWRX 300. So because of that, and we're interfacing with that, I wanted to get that feedback. This way there's a surety that it will work for you. This licensing approach enables existing and new regulators. Even if you're an existing regulator and you've only seen, let's say, Russian design, VVR 230, VVR 440, VVR 1000 or 1200, but you've never seen NuScale, forgive me for pointing you out a lot, or X-Energy or BWRX 300, or for that matter, an Westinghouse AP 1000 or an APR 1400 or 1000, or the Chinese design. If you've never seen one of those, it's going to be different for you irrespective of what time frame you have as a regulatory authority. So what we have done is to create this so that it assures you can do an effective and timely review while still maintaining the highest levels of safety, security, safeguards in providing protection for the environment and the public, because that's the ultimate responsibility for every regulatory authority. And in this case, what we're finding and are beginning to roll this out is that it's working, that it's resonating, that new regulatory authorities are picking up on what they're seeing. Now, it's still in its draft form. It'll be out final before the end of the calendar year, and hopefully in times for a lot of the things that you'll be doing. So Excel prides itself on the fact that it goes into these countries and is very supportive. 39 and a half years ago, I've never had a failed project since I started this company, and I don't intend to start now. So if I'm going to embark on supporting my brothers and sisters in Africa with their new nuclear build programs, I have to have the same confidence we're going to be successful that you do. And that's one of the reasons why we're doing all this. Right now we're doing this at our own cost because we don't think the rest of the world can get their head around it. And arguably, we're one of the best licensing organizations on the planet. We probably have more experience and expertise than anybody else. As I said, working in 29 countries, doing 13 countries' technology selection, setting up regulatory infrastructure and ministry infrastructure and owner-operator infrastructure, we've seen what works and what doesn't. I'm going to talk about the two other parts of that right now. The other part is regional considerations. Several regions of the world are very, very appropriate for this, a regional approach. Now, I mentioned this last year in Ghana, and for those of you that were here, you may recall that somebody asked me, and I'm going to try to quote, "Have you read your history? We don't like each other. We're not going to cooperate on the continent of Africa." I like, ooh, shucks, okay. Whatever history I read, I must not have read it deep enough. Okay. There's differences of opinion, differences of approach, geopolitical considerations, But to the extent that you can and want to and will get past that, there are approaches that can save you a lot of time, effort, and money in this approach. In several other places around the world, we are establishing a regional approach. We're working with this, kind of like when I was a director with NRC, we're looking at it from a perspective of, can we have some collaboration and cooperation of the regulatory authorities and the ministries, and for that matter, the owner-operators. In the United States, Excel manages the owners groups. There are 94 operating reactors in the United States. They're all a member of the PWR or the BWR owners group. Excel manages those. Why? Because we have their best interests in mind. We coordinate, we integrate, we develop the approaches and the processes and the solutions, interface with our regulatory authority to gain review and approval, then do all the implementing training and programs and processes. Because we're generic. We're not just Westinghouse, we're not just GE, we're not just CE, we're not just Framatome, we're not just Babcock and Wilcox. We see it across the entire perspective. That kind of approach can work for you on the continent of Africa. I've spoken to AFCON, I've spoken to some of your regulatory authorities at an IEA meeting. I had the privilege of helping the IEA write the 19 milestones document, SSG 16, about regulatory authorities, nuclear knowledge management, safety culture, and the list goes on and on. So we've seen how this can work. So new nuclear build infrastructure. Why recreate the wheel everywhere? Depending upon where you are, where others are, what works for you and your geopolitical applications, maybe you can take from others. Maybe you can share costs. Maybe you can share approaches. Technology selection. One of the things we may do in another place, and I'm working with 3 countries that are very close together, and what we're considering is building one nuclear plant in the center country and sharing the electricity. Picking one technology, sharing the cost, and doing it from there. In another location, we're working with 5 countries that are going to try to select, to the extent they can, the same nuclear reactor, small modular reactor technology, and then go to that technology provider and get a better cost because they're building 5 instead of just 1. So instead of paying 5x, you're paying, I don't know, I'll have to ask my colleagues at NuScale, maybe you're paying 3.5x or something. Something that reduces the overall cost so you share experience, you share expertise, you share activity, and you share construction costs, and you share the cost of the technology itself. Licensing. The licensing approach can be done on multiple regulators' approaches, irrespective of the fact that you may have different atomic laws. We're looking into that now to find a wider ways to do it. I'm just broaching this. I don't know how you feel about it, but it's worth bringing up because it's starting to take hold in several areas. And then construction and operation of new nuclear build technologies. These generic approaches that we're discussing look like they might take hold. And if they can, and they do, maybe you can consider that too. Now, I'm just giving you the overview and the concept. The devil's in the details. When we develop the specific applications, we'll certainly give that to you. But think about that. Think about how you might work with your colleagues in the other countries that are close by to you. Sorry, I went backwards. Construction lessons learned. Remember I told you the second thing that most of the financiers were about are construction risk. Because we've seen what happens. Construction rarely goes according to schedule or budget. And as a result, it's like, why would I invest this money and have it sunk into things that don't go? Unfortunately, in the United States, VC Summer was abandoned. Units 2 and 3 at about 55% each. Vogtle 3 and 4 were finished, but they were finished at significantly higher cost and longer time frames, and without a quality that should have been done. Are they safe? Yes. Can they go into commercial operation? Yes. But if you have to spend $100 million to fix quality issues, that's an add-on you weren't expecting. So how do you make sure you get those 3 things? Quality, schedule, and budget. You need to have somebody acting on your behalf to make that happen. Part of what we're doing right now is we're watching all the constructions around the planet. That includes TVO, with Okilioto 3, what happened in Flamanville with the French there, obviously Vogtle 3 and 4, VC Summer 2 and 3, some of the SMR constructions that are beginning, and other activities, and taking the lessons learned, the best practices to make sure that this doesn't happen to you. How are we doing that? We're developing an approach that takes all the improvements to design, procurement, engineering, and construction of a new nuclear power plant. I can't do that by myself. So what we did was we kept track of that when we worked with VC Summer at South Carolina Electric and Gas and Vogtle 3 and 4 with Southern. What we did was we listed every time the reasons for the overruns, the problems, the delays, the overcost, and the solutions for those, whether it's large build, small build, micro build, whatever. So we're trying to apply that globally. We're going to continue to update this based on everything we see, but we've already looked at this and already talking to folks, and we're talking to some of the constructors to say, integrate these things. Integrate these mechanisms to make sure you're protecting the best interest of your client, whoever that may be, wherever that may be. So we're trying to integrate that construction experience everywhere. What we become with you is your trusted partner. We come into your country and we become a worker with you. We become your partner looking out for your best interest, not the best interest of the technology or the constructor or the EPC. We're going to work with them because we need to, but it's your best interest. What do you want? Why do you want it? When do you want it? What do you want the next 10, 30, 50 years? What kinds of things do you want this reactor to provide you? Be more than just electricity, more than just an internal industry. And when do you want that? And how can we go about getting that in the most efficient and effective manner and to assure you're successful with quality, schedule, and budget? So in summary, we've seen a lot. We've been around a long time. I'm a former president of the American Nuclear Society and a fellow. I'm on committees and chairing committees with our Department of Energy, State, and Commerce. So I'm seeing what's being done and why. And I know what doesn't work and why. So my company and I, of which there's over 350 of us full-time and almost 1,000 part-time, we're here for you. And we believe you can be successful. We want to add value. We want to be a part of that success. And we thank you for taking the time to listen. And we're going to continue to find innovative and creative approaches to do the things that have been done before. Thank you.
Thank you. Thank you very much, Donald. No questions? Do you have any question for Donald? Yes.
Thanks, Donald. Shane from Lesedi, Cape Town. Two questions. At the start of your presentation, you made reference to cybersecurity. Can you maybe talk about cybersecurity in the context of what you've been looking at and how critical that is these days? So cybersecurity, one question. The other question relates to you observing Flamanville, Olkiluoto. Have you observed what they've done in China, Russia as well?
We've had the privilege to work in and around our Chinese colleagues. I worked with Snurdy for a while on your design of the Hulong 1 and things of that nature. That may surprise my Chinese colleagues sitting 3 rows up. So it is our intent, irrespective of the design and technology, to try to bring about the best approaches for that. All of the building of the Hulong 1, and you guys know this better than me, have only been in China to date. So we don't have as much detail on those construction experiences than if they'd been built outside of China. But it's my sincere hope that if we work with our Chinese colleagues from CNNC and others, that we'll find ways to share that kind of information. With the Russians, we worked with Rosatom before there was the invasion of Ukraine. We worked with them on their VVER 440s and 1000s that were currently built and being operated in Central and Eastern Europe. And then we worked with them on their VVER 1000 and 1200s that they were considering enhancements to and improvements to build in places like Egypt and Turkey. So we've seen those. We know what can be done to enhance and improve them. It's just a matter of getting to the people to do it. Now, we're an American company, and I can be candid with you, not everybody wants help. And I understand everybody's proud I can do this. I don't need any assistance. Okay, maybe. And I'm not saying that people aren't smart and aren't capable. But when you've seen a lot of these things, when you've seen what works and what doesn't, if you don't take advantage of the global nuclear industry experiences, practices, and best approaches, you might be doing yourself a disservice. There's a lot to be shared, guys, ladies and gentlemen. So what we want to do is to make sure you get it. Does that answer your question, sir? Thank you.
Thanks. Any other questions? Cybersecurity.
Oh, cybersecurity. Sorry, I couldn't hear that. In our country, in the United States, we have laws and restrictions and regulations related to cybersecurity. A number of those have come around over the course of the last 20 years, and you can well imagine, given some of the unique experiences we've had. So what I did was, knowing that that was an integral part of what we were doing in the safety systems, there was a gentleman who is now Vice President of of what I'll call critical infrastructure protection, which is cyber, physical, and information security. And make no mistake about it, each of your new nuclear build plants are going to have that. Physical security, cyber security, and information security. So I hired the person that was the Nuclear Regulatory Commission's Director of Critical Infrastructure Policy Protection. Protection policy. And what he's done is help us generate and put together a division of the company that sole function is to go out and make sure that the U.S. plants meet all the requirements of physical, cyber, and information security. We do inspections prior to the NRC coming. We set up and do training, make sure that we do evaluations of what they've already done. We find creative and innovative ways to come up with generic solutions. So we work with the Nuclear Energy Institute as well. So yes, we can do all of your cybersecurity protection activities, and we're currently doing that in all 94 reactors in the United States. I hope that answers your question. I can answer more if you want.
I have a question. Why are you convinced that nuclear will work in Africa?
Why am I convinced nuclear is safe?
Yes. Why are you convinced that nuclear would work in Africa? Because your opening statement, you said quite a number of people in the States don't believe it will work. Why do you believe it will work in Africa?
Well, we heard a presentation earlier today from a gentleman named Wisdom. Interesting name, right? And he talked about the fact that there's only been 3 events, major events, over the course of thousands and thousands of reactor years of operation. First, we have 3 Mile Island. Yes, we melted the core, but the reactor performed its function, so did containment. Zero radiation above that of environmental normal radiation. Okay? It was a very expensive test, very expensive from a standpoint of what happened, the cleanup at 3 Mile Island, and also the concern, basically the concerns that people expressed. Oh my God, oh my God, oh my God. Yes. The second one, Chernobyl. Now we all know, I hope, that at that time the Russians didn't have containment. So the Russians had a big test they were doing at Chernobyl. They had, I don't want to go into too much detail, but they disabled all the safety systems to get to a point they otherwise would never get to. And by the time they realized that wasn't going to work and tried to re-engage them, they didn't work. The reactor didn't explode. Nuclear reactors don't explode. They have a negative coefficient of reactivity, okay? What happened was a hydrogen pocket blew open the reactor, the top of it. Now, if that was inside a containment, no one would ever known. But it wasn't. So it blew right out into the yard. So you had both the people there and many others experience it. You may know that the first plant to discover it was in Sweden, after it had found its way and meandered all the way up to Sweden. Can you imagine? And then, of course, the third, Fukushima Daiichi, which totally could have been avoided. And now the Japanese have altered and changed their whole approach. You know, it used to be they had to get permission to do everything. In the United States, when we license a senior reactor operator, he or she has total approval. They don't need to call anybody for anything. They bring an emergency team and they make the decisions right there on site. Perfect example is they were trying to get permission to vent the Unit 2 secondary building. They couldn't get communication with Tokyo. Hydrogen explosion blows the roof off, continuous venting. Guess I don't need permission anymore. Sorry for being kind of funny about it. But the fact is, those are 3 events, all of which could have been, should have been precluded, all of which never should have been a part of the global public dialogue. But they are. So every time we go to talk about nuclear, there's this quote-unquote fear-mongering, where we have the people say, well, what about this and what about that? Then you have to take the time to explain it. And I've done that more times than I care to admit. Do I believe it's safe? I slept for 9 years on a nuclear submarine with a reactor 60 feet away from me. I hope it was safe. I actually entered the compartment with what we call an emergency entry on the submarine 3 times in 9 years. One time when we were under the ice, when we had to surface at the North Pole. I can't give you any more detail than that. So yes, I believe it's safe. I've worked around as a regulator for 5 years. I've worked around as an individual that works with and for owners and operators and ministries for another 39 years. I know this technology, and all these technologies are safe. They're more than safe. We build in redundancy, we build in diversity, and the new nuclear builds are a little bit safer. I am a big fan of large builds. They are safe enough, but there are things we have addressed in new nuclear builds, like NuScale has, you owe me for this, has done a lot of things to make sure that it's walk-away safe, that you don't have to worry about the structure, you don't have to have an operator stay, there's no requirements for diesel generators or AC or DC current, everything maintains itself. What other industry on the planet can assure you that level of safety? Trains? Absolutely not. Cars? Oh God, we know not. I don't know if you know how many people die a day in the United States from car accidents. 46,000 a day. Airplanes? Nope. You see the kinds of things that Boeing's experiencing right now. Let's blow out a window or blow out a door. Let's drop 12,000 feet and have all these people be hurt. So, and I'm not saying there's anything wrong with that. It's just that there is no such thing as zero risk. Every time you get up in the morning, there's a risk you're going to fall out of bed, a risk you're going to slip and fall. It's the same thing with nuclear. We have taken the risk asymptotically to zero by doing all these things. So I guess I gave you a very long answer. Forgive me, I'm not a very patient person. I believe nuclear is safe, and it's based on personal experience and expertise, and it's based on 54 years of working in this industry. I hope that answers your question, sir.
Thanks, Donald. We have one final question, and then we'll be able to have lunch.
Sorry for talking so long, but since we don't have lunch, by the way, I did suggest to your boss, Seth, order fast food. Go. I don't know how many McDonald's or Burger Kings or Kentucky Fried Chickens there are close. You know, we used to call it a submarine. You buy, I'll fly. You give me the money, I'll go get it. So I don't know how that's structured here on your continent.
The food is already here. They're just setting up.
So I'm the only one holding them from lunch. I'm so sorry.
So just one question and then we'll get.
Okay, me too. I'm so sorry to delay 1 minute from the lunch. Thank you very much for sharing this valuable information. Europe and Asia, those who own the nuclear, whether it's a plant or a bomb, whatever it is, today you agreed to bring here Africa nuclear energy. And according to my own perspective and analysis, you are here for a business, all of you. You are a competitors. Russia is here, China is here, America is here, Europe is here. But for the Africans, the only thing that we used to receive was that nuclear is something that's bad, that destroys the environment and the human or animals. And today, those who have created nuclear energy associations, they will have a very big problem with their community, because That is what you have been conveying for the last 40, 50 years. So my question is, I see that these institutions, whether they are countries or organizations, you are here for a business and you are here to make money. But for Africa, we don't have that money, number one. Number two, our people, they are afraid of the nuclear. That's number two. And I see that the business is extended. There are some who are talking about the technology and the expertise knowledge, others who are talking about the legality and the licensing, and others who are talking about the construction. So many different ways. So, and Africa, they are disorganized and they are not coordinated. So my question is, instead of just telling us to do what you want, why you don't let Africa do what they want? Thank you very much.
Okay, nice comment and question. First of all, I came to Africa a year ago, and I've been working with all your countries for free. So it's not just about money. Second, if you start a nuclear program and you make a mistake, we all suffer. A reactor event anywhere is a reactor event everywhere. What the Japanese did screwed America, okay? What the Russians did screwed the world. What America did with its 3 Mile Island event also messed up the industry. We have been struggling for 5 or 6 decades to prove to the world that we can safely operate facilities. So no offense, I'm not here for money. I'm here to make sure you don't make a mistake and my industry goes to hell in a handbasket, okay? So you want to be candid? I'll tell you what candid is. Africa deserves to have nuclear, but it doesn't know how to operate nuclear yet. And I'm not saying we do, but I think we do, because we've learned a lot from our mistakes. It's like your parents. They screw up and hopefully you learn from it. But it's not because their intents aren't good, hopefully. But anyway, what we've done is generations before you worked in nuclear to try to make it good, to try to make it better, try to make it successful. And they struggled through times when nuclear was the most underappreciated and underconsidered energy asset on the planet. In the United States, we have 9 energy assets: coal, oil, gas, wind, solar, hydro, nuclear, biomass, and geothermal. And nuclear was thought of as the last. But it was providing 20% of the rated thermal power and 60% of the zero emissions free energy. So people suddenly realized, holy shit, I can't go to a zero emission economy without nuclear, because wind and solar, bless their hearts, are intermittent and they don't provide any resiliency or reliability to the grid. If you try to have an energy grid based on wind, good damn luck. You're going to have blackouts 20 hours of the day. And that's not me talking, that's proof. We've got technological proof. Why am I here? I can't speak for why everybody else is here. I think that the other companies are here because they have a technology they'd like you to consider. I'm here because I want you to be successful. Because unfortunately, if you're not, I'll fail. My industry will fail. Something that I've given 54 years to will fail. Well, please don't the geopolitical aspects. I do disagree with a lot of things that are going on with the world. Hell, I even disagree with my current administration. Okay? But let me finish. This is important. Thank you for giving me this. We're not here to tell you what to do. We're here to suggest to you what works best. These programs and processes I talked about, what we're doing with regulatory authorities and ministries and owner-operators, we're sharing with them how an approach that may work for them. And then we're adjusting it to be country-specific. If your country wants to do it differently and it still works, I'm wide open to that. I'm all about creativity and innovation. I'm all about change. And I was when I was with the NRC 40 years ago. You don't just specify one way and that's the only damn way you can do something. That is a recipe for failure. I will tell you this. I think if you look around the room, and I understand your concern, I'm not saying what you're thinking is necessarily wrong, that you might have that impression, but I assure you, we're here because we want to be a part of your success. We're here because we believe we can help you get to where you want to go. We're here to help you get there in the best way possible and to the extent practical, the way you want it, okay?
Thank you very much, Donald.